welcome back to my online teaching platform. We are still on how to find the derivatives of trigonometric functions. You could recall that we learned how to differentiate the sine and that of the cosine. That is a function involving sine and that of what? The cosine. You could recall that in one of our lessons, we deduce the derivative of sine. That is, if you have y to be equal to sine x, we deduce the derivative to be dy dx to be equal to cos x, right? Cos x. And we also work on the derivative of the function y is equal to cos x. And we deduce the derivative of this function to be negative sine x using the first principles. Now we have another function which is y is equal to tan x. So we have to find its derivative, meaning we are going to find dy dx, or we are going to differentiate the function y with respect to the independent variable, which is the x. So having the function y is equal to tan x, you could recall that when we're treating trigonometry, we have a ratio for tan, that's the tangent. So the tangent can be expressed as you have tan x, the same as sine x divided by cos x. So we are going to replace tan x with sine x divided by cos x. So y will be equal to sine x divided by cos x, which is the same as y is equal to tan x. All right. Now, you consider we have a fraction, so we are going to use the quotient rule. So our sine x becomes our u, and our cos x becomes our v. All right. Now, let us put down the formula for find the derivative of a function when we are to use the quotient rule. So we have our dy dx equal to v multiplying the derivative of u, that's du dx, minus u also multiplying the derivative of v, which is the v dx, all divided by the v squared. All right. So you know our u to be the numerator of the function. So u is equal to sine x. So we need to find du dx, meaning we are going to differentiate the function u with respect to x. Now, you could recall that sine, when you differentiate sine x, we are going to get, or it will give us cos x, all right? Now, when you have your v to be equal to to be equal to cos x, you could recall that when you differentiate cos x, we had it to be negative sine x, right? So you can now plug in the various components into the formula. So we have dy dx equal to our v. Our v is cos x multiplying du dx. Our du dx is also cos x minus our u. Our u is sine x multiply the v dx. Yes, the v dx. And our dv dx is negative sine x. All right. They will divide through by v squared, and our v is cos x. So we are going to write cos x in bracket squared. All right. Now let's continue to simplify. Cos x times cos x will give us cos x squared. So we are going to get cos x squared minus, now we have negative sine x times negative sine x. So negative, we are going to get positive sine x squared, right? Then we divide it by, we have cos x squared, so we are going to get our cos x squared over here, right? Now, we have one of the trig identities, or one of the trigonometric identities as cos x squared plus sine x squared, giving us 1. So we are going to replace the numerator of the fraction with 1. So we know our cos x. If we say we have the numerator to be cos x squared sin x squared. So this is equal to 1. It's the same as 1. So just need to replace the numerator with 1. So this will give us dy dx equal to 1 divided by cos x squared. Alright. Now we can rewrite, if you have 1 divided by any number and the number is having any exponent, it's the same as 1 divided by the number in bracket, then the exponent that that number is having can be brought out. So you could say that when you apply the exponent to all the terms, or sorry, the numerator and the denominator in the bracket, 1 squared will still be 1, and you get back to your a squared, and you still get your a squared. So we are going to apply it here. Here we are going to write it as 1 divided by cos x in bracket squared. Alright. Now, 1 divided by cos x is the reciprocal of the trig ratio, which is the cos. So you see that we are dividing 1 by cos x, which is the same as the reciprocal of cos x. Now, we know that cos x, anytime you find the reciprocal of cos x, you are going to get sec x. So cos 1 over cos x is equal to sec x. That is the ratio. All right. So here becomes sec x in bracket squared. So this will give us sec x squared as the derivative of tan x. So we conclude that our dy dx is equal to sec what? X squared. All right. Or you can write it as d of tan x with respect to x is equal to sec x squared. All right. So this becomes a derivative of the tan x. Please kindly subscribe to my YouTube channel, which is Math with Ebefa, and do not forget to share with others. Thank you for watching. Bye. In our subsequent videos, we'll be learning how to differentiate functions involving more than one trig ratios. Maybe you will see a function having the product of sine and cos. You see a function having the sum of sine and cos, and you'll be asked to differentiate. So in our subsequent videos, we'll be treating how to differentiate complex trigonometric functions. Thank you for watching. Bye.